Today we'll be doing the final piece of conics, which is the hyperbola. So first I'm going to give you the pure definition. A hyperbola is the set of all points such that the difference, so notice how it's subtraction now, whereas an ellipse was the sum. This is the difference of the distance from two fixed points, and again that's going to be your foci, is constant. So again, that's the pure definition of hyperbola. So over here, I made a little picture. This is what a generic hyperbola would look like. So notice how it's basically two parabolas, each going opposite directions. This green dot right here, that's your focus 1 and focus 2 here and here. These purple dots, that's your vertex points right there. This red dot, that is your center. And then there are a couple other things here. You'll notice this box right here. That's actually like not part of the graph, but it helps you understand the graph. And then this top part of the box, that's called our EMA, same as an ellipse, and we're going to see that today a lot. And that's the basic idea of what's happening here. So I'm going to give you the generic formula. X squared over a squared minus y squared over b squared is equal to 1. So notice how it's pretty much identical to the ellipse formula, except now you have a minus. That's the key thing here. You have a subtraction sign, and that goes to right here. That goes to the definition of a hyperbola, versus an ellipse is the sum, and that's why an ellipse you'd see a plus right there. And for this one, we're going to put a note. A is always first. Okay, so there's our first equation. Now the other equation is if it flips around, where you'd have y squared over a squared minus x squared over b squared. That would equal 1. And again, you're going to note that a is first. So no matter how you do this a is going to be stuck right here, the b is going to be stuck right here, no matter what. And if it's y squared first, the orientation will look a little bit different. It's going to look something like this. So think of two vertical parabolas along the y-axis. Now a lot of people always ask, well, how do we know, or how can I remember that the y squared hyperbola is this one, and the x squared hyperbola is this one? So what I do is I think right here, this always hits the x-axis. So no matter what you do, if the x is first, it's going to hit the x-axis. So if you look at this thing, no matter where you draw these two parabolas or the hyperbola, if it's oriented this way, it must hit this axis no matter what. But notice how this does not hit the y-axis. So you flip it around right here. This will always hit the y-axis. Because no matter how you orient these two things, because they're vertical like this, it has to hit this y-axis no matter what you do. And to go back to the definition, to explain more deeply what that means, it basically means if you pick any point, let's say I pick this point right here, I'll do it in red. This distance, let's call it d1, to this distance here, let's call that d2. If I subtract d1, d2, take the opposite value to make sure it's a positive number, that will equal another point. Like let's say I go over here, if I connect this one, if I call this like D3, and I go here, I call this one D4, that will equal D3 minus D4. So no matter where you pick a point, essentially if you subtract these two lines, you're always going to get the same values. That's all that really means. So now let's go try to do an equation here. It says analyze the equation, x squared over 16 minus y squared over 4 equals 1. Let's do what we always do, info box. So we have our center. So for today, it'll be 0, 0, pretty standard. Our vertex points, our EMA, and our focus. So same as usual. We're going to put our lines down. And then it follows the exact same rules. Under the x, I see a 16, and that's a squared. So I'm going to go 4 out. 1, 2, 3, 4. That's our first vertex. 1, 2, 3, 4. That's our first vertex. And I'm going to go 2 in the y direction. 1, 2. EMA. 1, 2. EMA. So notice how it's very, very similar to what we've been doing with an ellipse. The only change now is I'm going to make a box. And the box should go through your vertex point and your EMA. Something like that. Now once you have that, here's a part that's going to be new. You have to draw asymptotes to create this effect. See these hyperbolas here? The way you draw those is you basically connect the corners like this. So you have the corners of the box, so that the diagonals, those are going to be your asymptotes. So I drew it not perfectly, so it's going to be a little hard to make this really nice. But there's our basic idea. And then once we have that done, now I can just use my vertex points and go towards your asymptote. And right there is my hyperbola. So notice already I can fill quite a few things in. The vertex points are plus or minus 4, 0. The EMA is 0, plus minus 2. We haven't done focus yet, but also make sure we all understand right here. Now some people ask, how did I know that the vertex was here, so the hyperbola is oriented this way? That's because the x is first. As soon as this x is first, my mental picture tells me it must be like this. So no matter what. If the y were first right here, then it would look like that. So now we have to do a couple more things. You've got to find this focus. The way we do that is this 3D box right here. Our new formula is c squared equals a squared plus b squared. Now on surface level, it basically looks like the Pythagorean theorem. That's because it's derived from it. It's very similar to the ellipse formula, except now it's a plus. And the reason it happens is going to be right here. So I'm going to erase this stuff to make it cleaner. If you look at our basic definition here, this letter C is the distance from center to focus. So same as always, distance from center to focus. And what you have to do is imagine you draw a circle here, like right there. And the reason you draw the circle is because right here I can see if I were to make a triangle from here to here, now I have a very nice right triangle. This distance is C, this is A, and this is B, and then that proves our formula. That's a relationship between A, B, and C. So knowing that, we just come back here, I'm just going to write that down. C squared equals A squared plus B squared. And let's solve it. So C squared equals A squared is 16, B squared is 4. So C squared is 20. So C must be the root of 20. So we'll just estimate, we'll put our focus like right over here, outside there, because that's going to be root 20 away. And then we'll label that plus or minus root 20 comma 0. We haven't really talked about these dotted lines, the asymptotes. So that's what we got to find now. So the final piece is going to be A for asymptote. And we want the equation of this line. Well, luckily for now, they all go through the origin. So that's really easy. That means we just got to find the slope. And notice how we just need the rise and the run. So for your asymptote, make sure you put this note, just find the rise over the run. And that's how we have this nice triangle, this nice picture here. Because I know this distance I can see is 2. This distance is 4. So I'm going to write y equals 1/2 x. And that's our first one. And the other one must be the opposite. So just write plus or minus, and we are done. Now let's try one more example. Find an equation of the hyperbola with center at the origin. So already we can make our info box. The center is the origin. We have a focus at 3, 0, a vertex at -2, 0. So let's write down our usuals. Center, vertex, EMA, focus, and now we have asymptote. And let's start filling in what we know. So our center is at 0, 0. We have a vertex at -2, 0. And then a focus at 3, 0. So if the vertex is here, that means that there's another vertex on the opposite side. So plus or minus 2, 0. The focus is here. There's another focus on the opposite side. So plus or minus 3, 0. And that's all we know. So just like an ellipse, once you're kind of stuck, use the formula they give you. C squared equals A squared plus B squared. C is the distance from center to focus, so I know that's going to be 3. So 9 should equal. And A is the distance from center to vertex, so that's going to be 2 squared, which is 4. So B squared must be 5. So B is the root of 5. So that tells me my EMA is going to be root 5. So let's go 1, 2, and some change right here. 1, 2, and a little bit. And I can fill that in now. 0 plus minus root 5. Now let's make our box. So with our EMA, I'm going to go through my vertex like so. So there's our nice box. Now make your asymptotes through the diagonal, or as the diagonal. And then let's open up our vertex for our hyperbolas like so. And then the only piece we need is the asymptote. So once again, let's look at the rise and the run. The rise was our root 5, and the run is 2. So pretty straightforward. Plus or minus root 5 over 2x equals y must be their asymptote. Now it'd be very easy to stop here, but notice how it said find an equation at the beginning, so don't forget to do that. Since it's this orientation, I know it got to be x squared over something minus y squared over something equals 1. Notice how the x squared is first. And in the x direction, it's 2, so that's our a value. So that got to be 4. And this is root 5, so we put 5. And there is our equation. So to recap everything, I made this nice picture for us here. So since the last two examples were the x orientation, I'm going to do a recap with the y squared orientation, just to make sure we understand what to do if it's flipped. So if it's y squared, this is a generic picture we'd have. And I'm going to draw my box to help us kind of see what's happening here. Remember, your vertex points are always going to be related to where the hyperbolas actually are. So here and here, if it's the y squared version, and if it's the x squared version, you'll see them on the x part, like the x-axis almost. Our EMA is on the opposing axis. And note that this right here, if that's your center, that's your A, that's your B, and of course, your center to the focus, that's your C. And finally, don't forget, the formula that links everything is C squared equals A squared plus B squared.